In this video, we will take a look at the topic, the static variables. Topic number is 6.11. The basic characteristic of the local variable is that it cannot be accessed after the termination of the function or its block. If you want to use the variable after the end of a block or end of a function, the variable must be declared as a static variable. Let's take a look at the left example. There are two function calls in the main functions. When we call the my function in the main function, the my function is started. First, we declare the variable number and initialize the value 10. Now we add 40 to the variable number, so the number variable has 50. At the second function call in the main, the my function is started again. The number variable is declared again and initialized 10 again. And then we add 40 to the number variable, and also the number has 50. The checkpoint of this example is whenever we call the function, the my function, the local variable is initialized 10. The point is, even if you call the function repeatedly, the previous result that was used in the previous function call cannot be referenced at the next function call. Hence, this example program shows only 50 twice. If you want to use the local variable at the next function call, we should use the keyword static. So you should declare the variable as a static variable. Once you declare the variable as a static, the local variable will be saved for the further use even though the function is terminated. In this right example, the local variable will be initialized once at the first function call because those are declared static. When the second function call is executed, the variable I and number will not be initialized. Hence, this function prints 90 for the variable number. Now let's take a look at another example with the memory layout. When we call the my function first, the my function is started, and the local variable is declared, and static variable I and number also declared and initialized. At the end of my function, with the first function call, this figure shows the status of current variable values. Let's take a look at details for changing values. The local variable initialized 100 and it never will change, so it remains the 100. And the static variable I is initialized 0 and increment to 1, and then static variable number is initialized 10 and add 40, the number remains 50. And now function is terminated and we are going to return to the main function as marked number 2. Let's take a look at memory layout marked number 2. At this time, the function is terminated, so all the local variable must be destroyed. But all the variable was declared as a static still remains in memory layout. In this example, the static variable number still keeps the value 50 and the variable I still keeps the value 1. After that, we call the my function again, and now it's time to declare for the local variable for the function. The local variable is allocated as a new space, but the static variable will not allocate new space because it is a second call. The static variables use the memory spot that were allocated at the first function call. Now let's take a look at the memory layout as marked number 3. Since we use the same space that were created at previous function call, we can reference the previous value 50 and 1. So now we add 40 to the number, so it's going to be 90. And also the static variable I will be 2. Now let's make an exercise for static variables. Let's make a program as shown in this video and clarify the purpose of static variables. Let's make a program and compile and run it, and explain why your program shows such results.